GARCH has many applications because, as you can remember, the standard deviation defines the data variation around its mean value. So if you are just thinking about differentiated data, how it behaves to jump back and forth around zero. And if you are thinking about an asset which is which value is determined by market, then obviously standard deviation is the market's confidence in terms of pricing. So is the pricing good, then the standard deviation is low, then the market confidence is high. Then if it starts to increase because there is a recession, then obviously they don't trust in the previous valuation, so market confidence will be lower. So that's why variance and standard deviation is changing in time. So it's a time variant variable. So we can have its unconditional value, which is not constant in time, but it's changing. So as a result, Boller-Slav developed the generalized autoregressive and heteroscedasticity model in 1988. And since then it's really popular because you can use it for option pricing, because for pricing options you need standard deviation in the black source model, but obviously if you are ignoring that the volatility can increase, then you can sell options for cheaper price than it would be reasonable. And this is how the partially wide long-term capital management defaulted in 1998, which was sad because they were responsible for half of the options market, and also because they got so many of the people got their Nobel Prizes before because developing option pricing equations. So since then, GARCH models are part of these models. Also, we can use it for value at risk assumptions, where we are just defining that under 1% or 5% of probability what would be the possible losses. And in macrofinance, we can use it to determine the riskiness of the market, so riskiness of the asset. And also there are other ways how we can determine the instability. There is this exchange rate stability ratio developed by Eisenman in 2010. And in this case, we can see that people used it before, so it's not a completely new thing. But here we can see that it just takes the time variant standard deviation from period to period, and after that it just checks that, okay, what happens with this data. And of course it will require some transformation. So for mostly data we need a set of daily data, so we have to convert them to have this range. But this is one way for estimation or for using the estimation of this exchange rate stability, because it will be really good. It fluctuates between 0 and 1. So if a currency is really stable, then it's at 1. If it's not stable or it's jumping back and forth, then we can see that some action is happening. Yes. Okay. I prefer to write about it so much. But sooner or later we should have some equation. Okay, what else? So, yeah. AI assistant. I had no problem with AI so much, but companies which are trying to push AI. So, in this case, to estimate EMP, for example, you need data about the volatility of the exchange rate, you need data about volatility of foreign exchange reserves, you need data about volatility of the interest rate. So in this case, fitting GARCH models is way easier because you will have data for each month or quarter of years or years. It matters what is the frequency here, than just using a rolling regression, because rolling regressions are outdated since the end of the 80s. So at least at this level. So yeah. Okay. So how can we fit them, or how can we estimate them? Within MATLAB, that's the fastest way, and I think it's easier just to check. Okay, so since we have already nice data here, then I will just load this one. Instead of here. I was able to create the shortest file name. Okay, and then let's just say that, okay, we need the volatility of for all of them. And also we have restrictions here because we know that we need all the rows, but so data from the 4, 5, 6, 7, so 47 columns. It's already differentiated, so I don't want to differentiate it again because that would create a disaster. Okay, so how can we estimate it? Unfortunately, the built-in GARCH models are absolutely rubbish. So there is a nice guy called Sheppard who erased some of his website, but so he works at Oxford University and he was creating the MFA toolbox, and it has way better functions than the original MATLAB official version. So that's why MFA toolbox.zip is here, so you can download it, you can extract it into your MATLAB folder, and after that you can just use it happily. Okay, I will just start it, but right now we just say that MATLAB should work from this folder. So obviously in your computer you have to change the name from my name to whatever you can find here. So that's one thing. It's nice to keep it here. Also, documentation is really good, and there are many examples how to calculate. So MFA Toolbox was supporting my PhD long time ago because I was able to do most of my calculations. So, okay, for a simple GARCH model, you can see already that it provides the description at the beginning. So this is the whole documentation behind it. Also, how can we use this? What are the inputs? And what are the outputs here and there? But I will go through the whole thing. We don't need these ones because they are optionals. And also we don't need that one. Okay, instead of epsilon, we are using ret 0.1. So we are just checking the interest rate in this case. Yeah, so which one is what? So we have parameter P, we have parameter O, we have parameter Q, we have parameter error type, and also parameter of touch type. So if we are going back to the original equation, then we can see that the innovation of this model was that we are thinking that current day's volatility on the market depends highly on yesterday's volatility. So obviously, if yesterday they were not able to price in the Hungarian forint, or their confidence was low, so that's why volatility was high already, then today they will be also not able to do that. So miraculously they don't get wiser. So this is the persistence of volatility. That usually the beta weight here is around 0.8 or 0.9. So it has a huge impact. Especially if we are checking data on daily or weekly databases. It will be interesting to see what happens with mostly data, but at high frequency data, volatility is absolutely glued to the past values. We don't have to go back much. So usually 1 day before, 1 month before, it will be completely enough. We can test it, but this is the experience. So going backwards, so how many legs are we including to the model will be determined by Q, and also how many days we are going back in terms of the shock variable. So we are imagining that, okay, there was yesterday's volatility here, which was contributing by 90%. What happens today? But still we need remaining 10%. So this will be generated by distribution. It can be normal distribution in this case, so some random variable will be thrown in the model, and in this case, today's volatility will be changing a bit, one way or another, or we can define other probability distributions which generate much more extreme jumps for us. So this is length of past shocks back in time. So one number for error term. So it can be 1. Right now the O is 0. I talked about it later. And the Q is 1, so earlier the impact of the So in this case, we are just saying that, okay, we are just looking for 1 month backwards. And error type, so this is what I mentioned here, that this can be generated with a normal distribution. Sometimes we need this, so because for option pricing, the whole thing requires normal distribution in the data, so the entire option pricing model is based on this one, or value at risk models, simple ones are also using this one. So sometimes we cannot use alternatives. In this case, we can see that we can choose normal, we can choose student t distributions or skewed student t distribution. I don't recommend this one. Generalized error distribution, you have many requirements, so usually we are just playing this or that. But first, let's just say that, okay, normal. Let's copy also this one here when we are trying to compare them. And Garch type, so this equation can be on squares. In this case, we are focusing on variances, or it can be just on one. Oh, I mixed this up. Okay, I have to correct this one. No way. So in this case, if it's just on one, then it will be a simple Garch model. Usually this is not the case, so it's only a majority, so it should be on 2. Variance or STD. In this case, if it's on squares, then we should not forget to take the square root of the data, because this will also provide variance, not standard deviation. Okay, so once we defined all the output, or sorry, the inputs, then we should run it, and after that I will show you that who is doing what. And what is your problem? Undefined at initial point. Yeah, there is missing data. Okay, so let's execute the listwise deletion. Okay, now it can work. So as I mentioned, that if something is not working for MATLAB, they will not start to reconstruct anything. They will just stop. And it's a good thing, because in this case we have some kind of a control. Okay, so parameters. So here we have a constant as the first parameter. This is absolutely 0, so nobody cares about it. We have a second parameter, which is the innovation or shock variable here. So this is the alpha parameter. And it's really funny that right now, this is responsible for the majority of the changes in volatility. So we can see that, okay, this is interest rate, this is monthly data, so 40 or 54% is just coming from this random number generation, and the remaining 33% will come from the past shocks. So at least central banks are doing their job. What would happen if I'm just using the exchange rate? Exchange rates are always strange, so that was the last one. Yes, okay. This is the book example of using Garch model. So exchange rates, stock market data will always provide you this. It's not overly managed like interest rates. So we can see that, okay, 76% of the change here will come just directly from last month's inability to value the currency. And shock is just 9%. It's really strange that really constant has weaker power, but okay, it's maybe because of mostly data. Okay, we cannot use log likelihood for many things, but this is what we are looking for, so plot. I mentioned already that we are using squares, so this is the HT. In any book, if you are just finding an HT, it means that this is variance or standard deviation, it depends on if it's in squares or not. But also, if there is the t, then it means that it changes in time. And they are not using Greek alphabet for some reason, so this is Latin alphabet for standard deviation. But square root must be done for getting standard deviation from this square data, and this is what I'm looking for. So we can see here that the standard deviation of the real effective exchange rate is changing from month to month. It's not a constant. So obviously this twin tower here is the 2008 crisis, which created shocks, and otherwise still is changing. So I think this is supposed to be the Eurozone crisis. Greek was close to default. One of these things should be the COVID. This should be the Russian aggression in Ukraine. So we can see that things were happening. That was the time when they were redefining the exchange rate rules, and this created a short-time shock. So we can see that this is highly useful, because otherwise, if you are just saying that, okay, but standard deviation of red in the end, we can use this, and in this case it would be just 1.3. We can see that, yeah, it's fluctuating around this. So they are not independent from each other. So if we just put out this constant here as a line, then we could see that it's fluctuating around it, just sometimes it's way bigger, sometimes it's way smaller. So this can be a problem. In this case, the problem is that we don't know that which variable or which model is the best fitting model intuitively. So it's always better to check that, or at least compare different models. And this is the time we can use the information criteria. So there is a nice function here which just gives us many different outputs, like archaic and Bayesian information criteria, but we don't want to load in everything, because from the inside we can just dig up. Yes, the EIC, there you are. And in this case I can talk about them as well. Multiple reasons to be included. So archaic information criteria. So first of all, looking for best fitting model. So that information criteria, it's over. So it's greedy. So it looks for models with more parameters. So it says that you should include more days backwards. It will say that you should include an additional variable. So this one, greedy. But it works really nicely for analyzing past data or historical data. Sorry. So if I have to calibrate any kind of regression, then I'm always using the AIC. If we need forecast, so this AIC is always pushing simple models. That's why for forecasting, VIC is much more preferred by the literature, and also you can see that it's working nicely. And both of them are really good because they are robust against outlier data. So they don't care, they are not affected by outliers. Then for calibration, we need log likelihood, which is given by big L's here. So, okay, we need parameters. Parameters are called parameters. So we can see that how many variables are within the model. This will be defined by parameters. The time t will define, okay, I should define it somewhere here. Is the length of the data set. And based on this, after that, they are just creating numbers for us. And until we have one model, then we can be really happy that, oh, I have this AIC, but I don't know that is this better or worse than another alternate model. So, so if we are working with GARCH models, we have to define at least 2 or 3 or more of them. So, not to overcomplicate everything, let's say that, okay, right now we are looking for simple model because no, we are using it for historical analysis, so we have to use the AIC. Okay, so let's copy it here. So the AIC was for normal distribution this number. So should we use the more fancier QT distribution, which is fat-tailed and is asymmetric, so it has many issues in all the different possible directions. So let's see that which one will be preferred. Okay. And just let's see that. This is for this QT. And in this case, we can see that for the QT distribution, this AIC was higher. And we are always looking for the lowest. So AIC was required. So in this case, we can say that we can still choose the normal distribution. We don't have to go for the fancy asymmetric fat-tailed thing here. We just say that, okay, it's good enough. It will do the job. Or, so okay, we can save it. Let's turn this back. Other key problem that in many cases, if you are thinking about the stock market, stock prices are increasing slowly with small volatility, but when they are starting to fall, when there's the drama, then obviously volatility increases a lot. So what happens that there is a feedback between the direction of the change of the variable and volatility. And that's why this asymmetry should be added. So we are setting it to 1. Then it means that now we are assuming that there will be a difference in the nature of the volatility if the market is increasing or decreasing. So in one direction it will increase. So for example, Swiss franc, when it appreciates, it has way bigger volatility when it depreciates, which is quite strange because usually the opposite is happening. So when Hungarian forint depreciates suddenly, then it has way bigger volatility than when it's appreciating. So let's see that if we are just switching it to 1, what will be the impact? Set to 1. And in this case, we can see that it's even lower. So this right now, this is the lowest. Okay, so it was appreciated by the model, and in this case, we were able to turn towards a GGR-GARCH. So the GGR is coming from the 3 people's name who were developing this ugliness, and in this case, we can see that now we have an additional parameter which highlights the relevance of this. And this can be really useful because if I'm showing you the parameters, then we can see that, okay, still past volatility is even more bigger, but also we can see that this asymmetry was highly important for them. So it's 11% is coming from this behavior of depreciating or appreciating under higher volatility. But at the same time, okay, this zeroed out completely the innovation, so everything was responsible by this for this one. And still the behavior is quite the same. So we were analyzing Swiss koruna. I don't know why I was talking about Hungarian forint. Different country. But still we can see 2008 crisis. So even if we are just using traditional well-functioning economies as an example, then we can see that okay, things were happening there. This one, I think this should be the dot-com bubble, something like this. So, yeah. But for the last 5 minutes, so if you don't have time to deal with any of this, then the best scenario is just check the DCC-GARCH model. So in past, many different models were developed during the whole 90s. And nowadays, if you are checking the literature, everybody just fits the DCC-GARCH model and then goes with the outputs. So nobody. For GARCH model, this is only good or best fitting model for Euro-US dollars. Otherwise, DCC-GARCH is always preferred. So this is my experience. Here and there can be examples when this is not happening, but it's a really good approach if you need any time variant volatility, just fit a DCC-GARCH model in any kind of a software, so it can be done also in eViews or in Gretel or in, I think, in Stata as well, or in R. Just for me, when I was learning it, I did it in MATLAB and it was easy control. So it's a useful application. Also, we can create simulations with this data. So if we need for forecasting, then also we can just use the variables. We can say that okay, I need 100 months data forwards. We don't have to define them because they are already defined. Parameters are defined. Oh, sorry, I can do that. I still have to keep them just. Error type is error type, touch type, okay, POQ. Good, so they are there. And after that, it will just create a simulation. Looking forward, so if you are just doing 100 of them and then adding them up, then we can create these nice graphs. So at risk management and financial management, we are playing with that one. But there is also a further application which can be useful as well, and this is the DCC-GARCH model. Okay, this will be strange. Because here we have not just one data point, but we have the whole variance-covariance matrix for the day. So if we need any correlation calculation, if you are interested in contingents between different markets, DCC-GARCH models are the gold standard. Because the problem is if you are just estimating any kind of correlation, then it will be biased by heteroscedasticity. So it means that or correlation is not just increasing because if it correlates better, but because volatility increases in one or both assets. So that's why this is since 2002, so since its development. Before of that, there was also back-GARCH, but that one is it's not that perfect, let's say, in terms of fitting. Okay, so this is how DCC-GARCH looks like. This is doing completely the same thing like the previous one, just it gives us the whole variance-covariance matrix instead of just one variance. So if I'm just hitting HT, so this is a stacked variable, so here we can see the rows. Sorry, so this is for each variable, this is for each variable, so in the main diagonal we can find the variance of, so this is the interest rate, this is the inflation, this is the output gap, and this is the foreign exchange rates variance for the first month, then for the second month, and so on. So this is going downwards, and also here we can see the covariances. So from this, after that, we can calculate easily correlation. Or we can also calculate betas for CAPM calculation if we need that one. So it can be also really useful. Okay, so first also let's see the correlation between the interest rate and between the foreign exchange rate, so the real effective exchange rate, because in this case the first one and the last one, first one variance is last one. Sorry, I should call this DCC-GARCH, otherwise it cannot. I could rename it, but it's faster to run it again. Okay, so now look. And now we can see that we really don't have much in common in terms of correlation, but sometimes, some months, it increases because of reasons I don't know right now. If you are checking currencies around the Eurozone, they have a correlation with the Euro around 0.8, 0.7. If we are, and if there is a shock, then they are dropping from this, and after that they are recovering. So, so that's why we have divergence there. If we are analyzing stock market indices, they are the opposite. So usually they are not correlating much, but if there is a shock, then the correlation increases until the crisis period ends, and then it drops back. So in case of bond markets, there was nothing, so what I was able to find. But these behavior patterns are well known in the literature or well described in the literature. So we can use it also as an input for regressions, but some people don't like it. So my bosses in Slovakia, they said me that it can also add some endogeneity to the model. So I have to check also that if I'm just using mostly correlations between daily data, then it was performing better than this one, because this will remove some of the relevance from a VAR model. But usually this also works nicely, just we are losing a bit significance here and there. So I still like this one. It has its limitations. So, if you are interested in this topic, then I also uploaded 2 or 4 papers which were written in this related to this one in the past, so it can be useful.